So today we're going to be working with finding the greatest common factor of polynomials, and then we're going to use that to factor out polynomials even further. So in a multiplication problem, the numbers that are multiplied together, those are called factors. And the answer to a multiplication problem is called the product. If a multiplication problem 5 times 4 is 20, then 5 and 4 are the factors and 20 is the product. And we can also reverse it by saying 20 equals 5 times 4. Or we can say we factored 20 into 5 and 4. The first step in factoring polynomials is to factor out the greatest common factor, and this is the largest integer and the highest degree of each variable that will divide evenly into each term of the polynomial. So in examples of 12 and 16, if you factor them all out, you see that you have common factors of 1, 2, and 4. However, 4, that is our greatest common factor. When we're talking about variables, if we're finding the greatest common factor of x squared, y cubed, and x to the 5th power y, we can, again, reverse that multiplying by stretching out everything that's in exponent form and then finding the common factors. So I have x squared, which is 2x's multiplied, and y to the 3rd, which is 3y's. And then we have x to the 5th times y, so it's 5x's and a y. Then when I'm looking at them, I see that they both have 2 x's, and I see that they have 1 y. And so x times y is x squared y. So there's our greatest common factor of this problem. Okay? If we have 6x squared y 8th times 10 y x cubed y 6th power z, we know that the common factors of 6 are 1, 2, 3, and 6. And I'm going to use 2 and 3 because those are prime. And then there's 2 x's and 8 y's. If I look at this one, I know that the factors of 10 are 1, 2, 5, and 10. 2 and 5 are prime, so I'm going to use 2 times 5, and there are 3 x's and 6 y's and 1 z. Now I can find my common factors, which is 2. There are 2 x's in each, and there are 6 y's in each. So that means my greatest common factor is going to be 2. There are 2 x's, so x squared, and there are 6 y's, so 6 to the y to the 6th power. You can go ahead and write them all out if you'd like, or you can take a look at them, and what you know is I know that 24 is 2, 4, 6, 3, 8, and 12. And then 36 would be 2, 3, 18, 12, 12. So they both have 12. So my greatest common factor in this one is going to be 12, not x, because this has an x, but this does not. So there's my greatest common factor. If I look at 2, I see that there's a 7 and a 21, and I know that 21 is a factor of 7, so there's my greatest common factor in numbers. And for variables, this one has 2 x's, this has 1, so that means that my greatest common factor is only 7x. If I take a look at these, I have 16 cubed minus 32. My greatest common factor is 16, because 16 times 2 is 32. If I take a look at this one, I have 7, 21, and 14. I know that 7 is a factor of each of those. This has got 4 g's, 3 g's, 2 g's. They all have at least 2 g's, so it's going to be 7g squared. This one, I have 9 and negative 27. I know that 9 is a factor of 27, so 9. This has got 4 m's. This has 2, so they each have at least 2. This has 5 ends, this has 3. There's at least 3. So my greatest common factor for this set is 9m squared n to the third power. Now these are just the greatest common factors. We know that there's more to each of these than just the greatest common factor. And finding those, that's called grouping. We always look first for the GCF, and then we're going to factor it out if there is one. The greatest common factor will stay out front and remain as part of your final answer. We can then group the 4 terms into sets of 2 binomials using parentheses. And we can factor, so the first thing we do is factor out the GCF. And then we need to make sure that the binomial remaining in each set matches, and we need to make sure it works. If it does not match, if you can make it match, maybe by changing the sign of what you factored out, do so. If you cannot, then there's no GCF and you're going to write prime. If it does, then write your final answer as the product of 2 binomials. And if there's a GCF, it's always going to be in front of the binomials. We're going to practice that here. This is called the box method, and it's really nice because it sets things up in a way that's easier to factor out. So our first example we have is negative 4d to the 4th power plus 8d to the 3rd power minus 12d to the 2nd power plus 24d. And when I look at negative 4, 8, negative 12, and 24, I know that 4 is a factor of each. However, my leading coefficient is a negative. And so what I'm actually going to factor out is not a positive 4, but a negative 4. So each of these has a negative 4 coming out of them. Now if I look at just the variables, I have 4d's, 3d's, 2d's, and 1d. All of them have at least 1d. And so that's why my greatest common factor is negative 4d. So that's my greatest common factor. Now, the polynomial that remains is the other half of those factors. So negative 4 times 1 gives me negative 4. So there's a 1 here. And d times d to the 3rd power gives me d to the 4th. So that's d to the 3rd power. And then on this one, negative 4 times negative 2, there's your negative 2, gives me positive 8. And d times d squared gives me d to the 3rd power. So this is d squared. Negative 4 times positive 3 gives me negative 12. So that's why it's positive 3. D times d gives me d squared. So that's why there's a d here. And negative 4 times negative 6 gives me 24. And if I take a d out of that, there's no d's left. So that's why it's minus 6. So the whole thing is negative 4d times d cubed minus 2d squared plus 3d minus 6. And what they want us to do now is to break that polynomial up into 2 binomials that will make this. And the easiest way to do that is to take each section and break them into 2 parts. Okay? This d to the 3rd power minus 2d squared, those go in the top 2 boxes. 3d minus 6 go in the 2 bottom. And what we're going to do is we're just going to extend these out so that I can come up with my binomials. To come up with those binomials, I have to factor out common factors. So if I have d to the 3rd power and negative 2d to the 2nd power, they each have a minimum of 2d's. And then 3d minus 6, 3 and negative 6 have a factor of 3. If I work my way down, negative 2 and negative 6, I have a negative 2 as my common factor. And d2 and d1 has a d. Now I'm going to take this information, and I'll go ahead and move on down here. D squared plus 3, d squared plus 3, that's one binomial. This one, d minus 2, that's my other binomial. So I know that my greatest common factor times the two binomials that I found create this entire polynomial. So there's my greatest common factor, and here's my first binomial, and there's my second binomial. The lovely part about this is those two binomials, it doesn't matter which way you write it. You can write d minus 2 times d squared plus 3, or you can write it d squared plus 3 times d minus 2. Okay? Doesn't matter which order you work it out in. Great way to see if it works is to find the product of these and see if it comes up with the same answer. Let's practice a second example here. So we have 6p to the 4th power plus 3p cubed minus 24p squared minus 12p. Those 3's are kind of hard to see today. So when I take a look at these, I have a 6, a 3, a negative 24, and a negative 12. And I know that 3 will go into each of those. So my greatest common factor will have 3. There's 4 p's, 3 p's, 2 p's, and 1 p. They all have at least 1 p. So now I'm going to put my greatest common factor out front, and I'm going to write down what I have left of my polynomial. So 3 times 2 is 6. P times p to the 3rd power gives me p to the 4th power. 3 times 1 is 3. P times p squared gives me p to the 3rd power. 3 times negative 8 gives me negative 24. P times p gives me p squared. 3 times negative 4 gives me negative 12, and p times 1 gives me p. So there's just negative 4. Now I'm ready to break my 4-term polynomial down into 2 binomials so that I can work with them. And so I am going to take these two and these two. I'm going to put them in my box. And then I have 2p to the 3rd power, p squared, and I have negative 8p minus 4. So when I'm looking across here, my greatest common factor of these two is p squared. On these, my greatest common factor is going to be negative 4. On these, it's going to be 2p. And on these, the only common factor they have is 1. So I'm going to have p squared minus 4 and 2p plus 1. So my factor of this polynomial are 3p times p squared minus 4 times 2p plus 1. And again, if I want to double check to make sure I have the right answer, all I have to do is to go ahead and factor out the two binomial, to find the product of the two binomials and then multiply that by the greatest common factor that we discovered. And when you do that, you should come back to the original problem. If you don't come back to the original problem, then there's a mistake. If you have any questions, please make sure that you speak with your teacher. Thank you.